Time for part 2 of this video. I'm going to show you how to troubleshoot a microwave that is malfunctioning. Sadly, this one is working at the moment. So let's do this one more time. Yes, I've already taken apart this microwave, take the cover off. I will show you what happens if this diode gets shorted and we got no fuse. Here we can see the schematic of a microwave, and the most common component that I have seen that goes short circuit. When that happens, all the current will flow to the capacitor from the transformer and back this way to the transformer, so we will get a resonant circuit. And if that happens, I think we will see less reactive power on this side. I'm going to try it out. I'm going to short out this diode here. I will see what happens. Yes, here we go. I removed the diode, which lays there now. I'll put this shorting wire here instead, directly to ground. And I still got the fuse here, so let's see if it blows. And yes, of course it didn't blow, and you can hear the very special sound from the transformer. That's a special sound you only hear when the diode is shorted. If I look on the power meters, we don't pull so much power, and almost no reactive power as well. And a shorted fuse will not blow the fuse. And a shorted diode will not blow the fuse. You will see that. Let's begin with shorting the magnetron. These two pins to ground. Here's the magnetron. And that's actually a capacitor, the connector here. So I'm going to unplug these two and connect it to the metal case directly. So as you can see here, I shorted out these two wires to ground, and this is a pretty bad idea. I don't think this capacitor goes short circuit like this, because now the both filament wires are shorted out, so I will have a lot of current going into that. But I don't want to have it turned on so long, so I don't damage anything. So yes, let's turn it on and see what happens. I should plug it in first. So yes, let's see if it blows the fuse. Still, we got a pretty special sound from the transformer, even though the diode is there and it's working and everything else working. Let's have a look on the power meter. Let's turn it on. You can see there we got more power and almost no reactive power. And because we got more power here, because of my filament is shorted out, and the wires get pretty hot. So yes, hopefully that will not happen so often. Shorted magnetron. And it's always discharge the capacitor before you do anything. And unplug it. You should actually unplug it before you short the capacitor. And the next thing I have seen as well is a shorted capacitor. That's where stuff gets getting funny, because with all the current going through directly to this transformer again, and it will blow the fuse. If we don't have the fuse here, it can actually, one is to burn this transformer. Hopefully there's a fuse here that blows before anything bad happens. Yes, now I shorted the capacitor, and the diode fuse will blow, and because this capacitor is the only thing limiting the current as well, because it acts like a capacitive dropper for the magnetron. So yes, let's see what happens. So yes, now we saw how a fuse burnt. Before we completely ruin this microwave, I'll try one more experiment. This is the light bulb up here. You've all seen that one. If you try to open it up, and that looks pretty nasty. And what happens if you put it in there and turn it on? Something is happening. I don't know what happened. Holy shit, it's fucking on fire! What happened? I ruined my Magnetron. Yes, what happened? And now we should discharge the capacitor. Oh, I need to turn it off first. Safety first. And here we can see all the microwave components. Here's some circuit board, and there's the transformer, the fan, the magnetron, this capacitor, turntable motor, and over here we've got the diode. So yes, but now we're just going to have a look at these two components, the magnetron and this capacitor. Look what happened to a magnetron. It completely self-destructed. It didn't like that light bulb, or maybe run unloaded. Violet pink things can be beryllium oxide, which is very dangerous. So we'll need to be careful to not break this insulator. And here we got 2 large magnets and 4 cooling fins. Yes, first let's begin taking this magnetron apart. I will take one piece of tape first and put it on this insulator, just for safety. If anything happens, we bend these parts over like this, carefully. And now the top is kind of free. And here we got the holder, it holds everything together. Let's remove this braid first. These are like preventing microwave energy to getting out. Like this one was pretty good stuck. So let's continue. Bend these 2 parts a little bit off. And now we need to get the bottom off. And in here we got 2 inductors and another insulator, which is dangerous. I'm going to remove these inductors first. Just like to cut one here and here. Same with that one. Put the inductors out. And now I can put a little bit more tape around that and we can pull the whole thing out. Now we've got the tape here. Now I can just pull it out like this. Now we've got the magnet here. And this is scrap metal. Now I can remove this on the top here and get this magnet out as well. And here we got the actual vacuum tube with the cooling fins. So now let's take apart this capacitor here. And this is important. You should not do this, or not even keep capacitors which contains PCBs, because PCBs can be really dangerous as well, especially for environment. And yes, this one should have a 10 megohm resistors across the capacitor. You'll see that when you take it apart. made in Ningbo, China. This is a new one. This one has oil in it, or all these capacitors has oil in it. So you'll see when I take it apart. There's actually I filled it oil with, sealed it up with some bit of solder. So let's cut around it and see what we got inside. So yes, now the capacitor is open. There's a lot of oil everywhere. So this is still not so good oil to like throw it away in the trash bin, but I think I will do it.
How dare you!
Yes, and inside of it here, so there's a pile of oil still left in here. I want the oil to get underneath. Here we go. Oh, I lost connection. So here you can see it. And here we got the resistor that we was looking for. I like pull it out. Here we go. Here you can see the aluminium. And we got the oil in there. Cheers. Yes, now you just see the capacitor here. Got some special tape around it, so I take my little knife here and cut it into. I'll take this tape away. And that wasn't actually tape, it was like all the plastic which is used to insulation. And here you can see the aluminium, the first plate. And here the second plate begins. And it's like this all the way around. Two plates stuck to each other and rolled like this to give it more capacitance. And it will take less space as well. Like getting rolled around each other like this one, and I should really have gloves on. And here was the top part with the resistor here. Sometimes these resistors can like get open circuit, or maybe the solder can break, but this one isn't soldered, it's like a press fitted. So I think that sometimes these resistors can be faulty, so always discharge the capacitor. Hope you found this video interesting. Thanks for watching.